We are going to keep working in chapter 7 here, working with the normal curve. And in this section, we are going to actually interpret the area under the curve and find, working backwards, find the value that gives you the certain area. All right, so first, what we are going to work with is the standard normal curve. So suppose that the random variable x is normally distributed with any mean mu and standard deviation sigma. Then we can calculate what's called the z-score, or the random variable, by taking what we got, our data value, minus the population mean, all divided by the standard deviation. And what that's going to do is it's going to give us a standard z-score, which we can then use in the standard normal curve to find along the curve where the area would be. So just remembering that standard normal curve has a mean of 0 and a standard deviation 1. So here's our standard normal curve. So in the middle is 0, and what these are going to do is 1, 2, 3. You go up however many. I always like to go up 3 and back 3. And what's going to happen is you're going to get a z value, or a z-score. And that z-score is going to tell you, 1, if you are above or below the mean, and then how far you are above and below the mean in terms of standard deviations. So if you had a z-score of 1.5, because it's positive, you would be above the mean by 1.5 standard deviations. Above the mean, 1.5 standard deviations. If I had a z that gave me negative 0.75, negative means that I'm below the mean by 0.75 standard deviations. Okay, so it's a way to just tell me where my data value falls in relation to the mean and the average. For example here, IQ scores are modeled with a normal distribution. The average IQ score for the entire population is 100, and our standard deviation is 15. Okay, an individual whose IQ score is 120 is 1.33 standard deviations above the mean. And here's how they got that. It's always your data value minus the mean all over the standard deviation. So our data value in question is 120. You take 120 minus 100 and you get 20. That is divided by 15, and that is how you get the 1.33. So what that means is this score is 1.33 standard deviations above the mean. And then what we can do is we can use our normal calculator to determine the probability of getting that result. In order to get that calculator, in StatCrunch, we will go to Stat, then click Calculator, hover over Calculator, and then click Normal. All right, so Stat, hover over Calculators, click Normal, and it automatically puts my standard normal curve here. 0's in the middle, up 3 deviations, back 3 deviations. So my value was 1.33. So 0.908. That means that's about just shy of the 91st percentile. So having a IQ score of 120, you are in the top almost 91%. You have about 91% of people below you and about 9% of people that would have a higher score than you. So you're pretty smart if you've got that IQ. A pediatrician obtains the heights of 3-year-old female patients. The heights are approximately normally distributed with a mean of 38.72. So that is a key piece of information, and a standard deviation of 3.17 inches. That is also the key piece of information I need. Use the normal model to determine the proportion of 3-year-old females that have a height less than 35 inches. So what we're trying to find is the proportion or the probability that our females in question are less than 35. Okay, so the easiest way to do this, I'm going to show you here. Instead of using this formula, you can use this formula. I'm going to show you both ways. I can also just enter the values into StatCrunch. All right, so let's say I wanted to do it the way we just did it with finding the z-score. Our data value in question is 35. I want to subtract the overall mean, 38.72, and I'm going to divide that result by 3.17. So I take 35 and I subtract 38.72. That gives me negative 3.72, of which I'm going to divide that by 3.17. And I get negative 1.1735. There's going to be a whole bunch of numbers after that. Usually a z-score, we just go to 2 decimal places. So I'll just do that, negative 1.17. All right, so then I could go back to my StatCrunch here. Open back up my normal calculator. And we type less than negative 1.17. Okay, so 0.1210. Usually the way we do this, it's 2 decimal places for this box, for the z value, and we usually go to 4 values for the proportion or probability. So 1210. Probability, we get less than that, and that should be a z, is 1210. Okay, so that's option 1. Option 2 is going to actually be typing in the values of the mean and standard deviation and the data value in question here. So what we're showing you here is how I could type this whole stuff into StatCrunch. So what I could do is, if I go back here, I have the option to enter my own mean, which is 38.72. I have the option to type in the standard deviation 3.17. And I want my data value in question to be 35, and we selected less than that 35. Usually what I like to do is I like to click this guy here, because then it shows me the exact mean and my standard deviation values. This is the way we like to, this one here, 68, 95, 99.7. I always like to select that on. It is not defaulted, so please select that so you can kind of see that here's that 1 standard deviation, 2 and 3 standard deviations. It just graphs it how I graph it when I draw it on hand for you guys. So then what it does is it finds the value of 35, and it's going to mark it here with that vertical line, and then it shades less than. So our value here, 0.12029, so 1203. It's going to be slightly different than the one we did by hand because we rounded. 0.1203. 0.1203. And on this slide, we had 1210. So this is because we rounded this, but they're still close. 1, 2, and 1, 2. They're just slightly off. It is okay, I promise. It just depends on which method you use. When you are doing them in StatCrunch or doing them on a test, know that there is a buffer. If you're going to type in the value, they do give you a little bit of leniency for rounding. So it will still accept both of those answers. Here you go. This is the exact graph in StatCrunch. So it indicates that the proportion of pediatricians' 3-year-old females who are less than 35 inches tall is 0.1203. And also remember, we could say the probability of selecting one of the pediatrician's 3-year-old females who are less than 35 inches tall would be that same value. Just remember, we can always write those two statements, the proportion of or the probability of selecting, and then the rest of it is all the same. It's just how you start it. Okay, but because this one specifically asked for the proportion, we wrote our interpretation in terms of the proportion. Just remembering that because it's a proportion, we can also relate it to percentiles. And remember that anytime we talk about the percentiles, the value we get, so let's say it's here, it's so it's always going to be shaded to the left. So 0.42 is this way. So 42% would be below. And then the remaining of the, what would that be, 0.58? Yeah, 58% would be above you. So in this case, 12% of the females would have a height less than 35 inches, and then the remaining 88% would be greater. So because our value here was 0.12, 12% are below 35 inches, and 88% are above. So lots of different ways we can write interpretations about them, a lot of different ways that we can pick out that information. So let's go ahead and ask another question in regards to that same data set. All right, so for the pediatrician presented in the previous example, find the probability that a randomly selected 3-year-old girl is between 35 and 40 inches tall, inclusive. So that is, find the probability that X is between 35 and 40, or 35 is less than or equal to X, which is less than or equal to 40. All right, so I'm going to open back my StatCrunch here, and it still has all of my information in here. Remember that I can do less than and greater than here. If I want a between, I have to select the between button up here. And we want to go between 35 and 40. And again, I always like to leave that 68, 99, and 95% mark. That shows the standard deviations, the best way to look at the graph. Our answer here would be 0.5365. We'll always go to 4 decimal places. 1 is after the 5, so it does not change the rounding of that. So 5365 should be my answer. And we can put you here on the other screens. So again, draw your normal curve, shaded between 35 and 40. Gave us the exact same answer there, 5365. So that is our result. So what does it mean? The probability a randomly selected 3-year-old female between 35 and 40 inches tall is going to be 0.5365. Or about, if I were to round this, about 54% of our females, 3-year-olds, are between 35 and 40 inches tall. Or I could say the proportion of 3-year-old females between 35 and 40 inches tall is 0.5365. So it's just a matter of how you want to interpret that, how whatever you're reading, that person wanted to write the result in terms of probability, proportion, or as a percent like this. In the end, if I were to randomly select 100 3-year-old females, we would expect about 53 or 54 of them to be between this height. Now, why did they say 53 or 54? Well, because it's 536. It's not 53, not 54. In general, if we were to multiply that by 100, 0.536 times 100, 53.6, so 53 or 54, around there. In a perfect world, it would work out to be one of those two numbers. That is what we would expect. We always know that in the real world, if I were to grab 100, it may not be exactly 53 or 54. Maybe it's 55, maybe it's 52. There is a chance for a little bit of leeway in the real world, but this is what we expect based on probability. Just remember, if we want to find a left, we're going to use the less than symbol, and it will be shaded to the left. The area to the right is a greater than symbol. And then for area between, we're going to click that between button. And then we have two values we have to type in. Again, you always have the option to do these by hand if you wanted to. If you wanted to find the z-score and then type the z-scores into the calculator, that's fine. For me, it's easier just to plug it into StatCrunch, give me the answer, and then I just have to interpret it. Okay, that is always my goal for you in this class. Use the technology to help you. All right. If you were to calculate the z-score by hand, you're still going to have to use StatCrunch to get those values. So I just go straight to StatCrunch, be comfortable with it, be familiar with it, and then take that answer and interpret it. Okay, that's the part about this class that is so different than an algebra class or a applied calculus class. Okay, we want you to use the technology to help you get that answer, and then you need to be able to interpret what it means. Just remember that the normal curve does extend infinitely. So there is no specific range of values that we can say, oh, I have to specify here to here. That curve continues. We can have really, really low values, really, really high values. It is possible. Just remember that the entire area does equal 1. There may be times when you do a test here and you get 1. Okay, and that is okay. What it's basically saying is that you've pretty much reached the end here. This is what you've selected is within the range of like everything should be within here. There are times when we run a test and you may get a value of 0. That means it's really not possible to happen, really not likely to happen. So just know that you may come across those. Some, depending on it, it may write 0.9999999 instead of 1, or it may write 0.00001 just to show you that, hey, there is still that slight, really, really, really small chance that it could be, but it just depends on how the software is going to spit out the answer to you. Now we're going to go the opposite direction. So we're going to have our original mean standard deviation, and we're going to be given the probability value and say, hey, what value gives me that probability? Still working with the same data set. The height of pediatricians' 3-year-old females is still normally distributed. Our mean, 38.72, standard deviation, 3.17. What we want to do now is find the height that gives me the 20th percentile. The 20th percentile means 0.20 is the area. And anytime we do a percentile question, what we have to do is in our probability, we are looking for X is less than what value that gives me 20%. We want 20% to be below the value, 80% to be above. This shows generally what we're looking for here. We're looking for the X that gives me that area to the left is 0.20. So the way we do that in StatCrunch, get my calculator back up here. I'm going to go back to standard. Okay, so I still have my mean and my standard deviation. This time what I'm going to do is I'm going to enter my value here. So 0.20. And as soon as I type a value, you'll see that the box next to it disappears. You can only type in one of the two. And when you type in one of them, it deletes out the result from the other. Okay, I can then hit compute and it's going to give me the value here. So 36.052, 2 does not round 5, so it's 36.05 is my value. And I believe if I do that here, you're going to get that same answer here, 36.05. I rounded to 2 places. It looks like the answer here rounded to 1, 36.1 inches. Whichever way you wrote it here would be fine because they didn't specify how far to round to. The scores earned on a mathematics portion of the SAT of a college entrance exam are approximately normally distributed with a mean of 516 and a standard deviation of 116. What scores separate the middle 90% of test takers from the bottom and top 5%? In other words, find the 5th and 95th percentiles. So there's 2 ways that we can do this. I read this first as the middle 90%. So I'm going to do that as a between, and area is 0.90. 516 and 116. So 516 for my mean, 116 for my standard deviation. I want to do a between such that my area is 90%, 0.90. That is the way I'm going to do it here. And what it's going to do is it's going to give me my 2 values. I like my, so 325.2 and 706.8. 325.2 and 706.8. My guess is it's going to be whole numbers for the results of 325 and 707 if I rounded to whole numbers. So that is one way to do it. You can see here, area between is 90, which means I have 5% below and 5% above because I've split it. So you can see the between gave us the exact same values. So the way that we interpret it here, the SAT scores that separate the middle 90% of the scores from the bottom and top 5% are 325 and 707. Okay, we could put it in another way and say a student who scores 325 on the SAT math exam is at the 5th percentile. And then a student who scores 707 on the SAT math exam is at the 95th percentile. And then we could use those results to identify anything that would be unusual. Because remember, unusual, we've always kind of set as that standard of 5%. So any score less than 325 would be unusual. And any score greater than 707 would be unusual. Okay, does it happen? Yes. Is it common to happen? No. You may see the notation here. Z sub alpha, which is going to represent the Z score such that the area under the curve is to the right. So a lot of times we just use Z for the left. Z sub alpha is going to be for the right. Really, it's just a notation. You're going to be using StatCrunch, so it's not super important for you guys to know that. All right, but what they could ask is they could say, hey, find the Z value of Z 0.10. So what that means is it's saying the area to the right of an unknown Z value is 0.10. Or we could say the area to the left is 0.90, the remainder. So it's up to you how you want to look at it. It really doesn't matter if you want to do it in terms of left or right. But when they write it like this, find the value of z sub 0.10. They're saying what value here gives me an area to the right that is 0.10. And we would just, again, use StatCrunch, just changing that symbol to be greater than. So I can ask to the left, I can ask to the right, I can ask between. For any continuous random variable, the probability of observing a specific value of the random variable is 0. We cannot ask a specific value. I can't say, what is the probability of getting equal to, okay? We can't do that here. All we're doing is we are taking ranges. So it has to be a range. There has to be a low and a high. A low and a high, or a between, where you have a low and a high. So just know that you'll never be asked the probability equal to. You can't do it. We always have to have a range. All it's saying here is it doesn't matter if you write these as less thans or less than or equals to, the answers are going to be the same, because you can't, including that one value doesn't change the answer. What we're going to do here is just going back to the standard normal curve. So anytime you see standard normal curve and you've been working with the normal calculator, what you have to do is you have to default it back to zeros and ones. The standard normal curve means the mean is 0 and the standard deviation is 1. All right, so we want to the right of negative 0.55. So right, negative 0.55. And there is our area. So the area for that first one, 0.7088. If you want to pause and try these and then check the answer, you have every right to pause and then come back and check your answer. I want another right. So greater than 2.23. And I can always double check. Lies to the right means my shading should be to the right. If it is not, I need to change my symbol. 0.0128. That 7 is going to round that 8 up. So 0129. Next asks for a less than. So I'm going to change it to left. And 1.35. So this one is 0.911. Let's see, that's going to round to a 5. 9115. Okay, still to the left. I'm going to change my value to negative 1.75. I have 04005. 5 is going to round that to a 1. So 0401. And these last two are going to be betweens. So I need to type two values, negative 2.04 and positive 2.04. There we go. Let's try that. 95864 is not going to round it. So 9586. Negative 1.67 and 0. All right, 4525. Working backwards, find the z-score such that the area to the right is 0.07. Still working with standard normal. Go back to standard. I want right, so I want greater than, and my area is 0.07. Anytime we're finding the z value, we only go to two places. So 1.475 is going to round that to 8. 1.48. Area to the left, we are going to change it to a less than symbol. And remember, area goes over here, 0.42. This one is negative 0.20. And our last one is the area between is 0.80. And anytime you do one like this, you're going to get both answers to be the same. One is positive, one is negative. Negative 1.28 and positive 1.28. So one easy, quick way to write that is positive and negative 1.28. So the mean incubation time of fertilized chicken eggs kept at 100.5 degrees Fahrenheit in a still air incubator is 21 days. Okay, so there's my mean. Mean is 21. Suppose that incubation times are approximately normally distributed with a standard deviation of 1 day. All right, so let's see what we got. Draw a normal model that describes egg incubation times of fertilized chicken eggs. So what we want to do first is just create my normal curve. So I can go right here. My mean is 21. My standard deviation is 1. And then I don't have to, I can just click compute. I want my, it's going to give me my 69, sorry, my the 68, 95, and 99.7 values. So there is a normal curve. So middle is 21, up by 1, 22, 23, 24. Go back 20, 19, and 18. You can either draw that by hand or you can share the image that I just gave you there. All right, B, find and interpret the probability that a randomly selected fertilized chicken egg hatches in less than 20 days. We want to go less than 20. All right, let's go back to standard, and I want less than 20. I got 0.1587, 0.1587. Okay, so find it and interpret it. So what does that mean? The probability of a random selected egg hatching in less than 20 days is 0.1587. I'm going to pick some different colors here just so it doesn't all blur together. Okay, C, find and interpret the probability that a randomly selected chicken egg takes over 22 days to hatch. So now I want to go greater than 22. Okay, so you really just have to make sure you're reading correctly so that you know what symbol to type in or to. So greater than or over means greater than, and I want 22. Okay, it is going to give me the same answer because it is 1 standard deviation above, whereas the other one was 1 standard deviation below. So same answer here. So the probability of a random selected egg hatching greater than 22 days is 0.1587. I'm going to probably put D up here just so that I have enough room to write it. Or let's see, I may be able to fit it here. All right, find and interpret the probability that randomly selected fertilized chicken egg hatches between 19 and 21. Okay, so that right there tells me I'm using the between button. And I'm doing 19 and 21. All right, so I have 0.4772. So the probability of a randomly selected egg hatching between 19 and 21 days is 0.477. Okay, and I always use the interpretation based off of the questioning. So it's saying interpret it in terms of probability. If it said proportion, you would say the proportion of fertilized chicken eggs that hatch, whatever you're asking for. Okay, so just always look at what it's asking for, proportion or probability, to know how I write my interpretation sentence. All right, and then last question, E. Would it be unusual for an egg to hatch in less than 18 days, and why? All right, well, let's grab our calculator here again. I'm gonna go back to standard, and I want less than 18. So less than 18, you can barely see it. It is there. There is a small little marker red there, 0.0013. So is that considered unusual? Yes. Okay. Anything less than 0.05 is unusual. So 0.0013 is less than 0.05. So yes, it is unusual. I do have one more example here, but I want to draw your attention to if you ever get stuck and you're like, oh my goodness, how do I type these in? I don't remember, where do I go? What buttons do I press? What number goes where? All of that, again, is in the course under the weekly lessons tab. So under weekly lessons, find the week. It is in the review document. Oops. There it is. Okay. So you're working and you say, I don't remember how to do this. Right here, using StatCrunch, what do you do? Working backwards, what do you do? Okay, exactly telling you what to do. Enter probability here. Clicking compute shows the answer here. So it shows you where you're going to go, where you type your information, how you get your answer, all of that. Okay, so anytime you get stuck, if you don't remember what goes where, how do you do the specific problem, always go back to these review guides, or chapters coming up for 9, 10, and 11 have a specific StatCrunch help guide that I've created for you guys. So just remember that those things are there to help you. I do have one more example here that we can do. All right, so let's see. Ball bearings are manufactured with a mean diameter of 5 millimeters. Because of variability in the manufacturing process, the diameters of ball bearings are approximately normally distributed with a standard deviation of 0.02. All right, so immediately I say, okay, at my normal calculator here, I have a mean of 5, a standard deviation of 0.02. I'm going to enter that in just so I'm ready. All right, what proportion of ball bearings has a diameter more than 5.03? So more than means greater than, and I have 5.03. Okay, so you'll see here my standard deviations marked. 5.03 is exactly between here, so it's like 1.5 standard deviations above normal. And we get 0.0668. All right, any ball bearings that have a diameter less than 4.95 or greater than 5.05 are discarded. What proportion of ball bearings will be discarded? All right, so we have to do this in 2 steps. We need to know less than 4.95 and greater than 5.05. All right, so less than 4.95. So let's do that one first. 0062. So less than is 0062. Greater than, let's check that one. And if you've already know, some of you may know that you're going to get the exact same answer here because they're exactly 0.05 above and below. You're going to get the same answer, but the same distance. I went up 0.05 and I went back 0.05. Because the curve is symmetric, my answers are going to be the same. 0062. So combined, if I add those two together, 4, 2, carry the 1, 0.0124. So about 0.0124 are going to be discarded. Using the results of part B, if 30,000 ball bearings are manufactured in a day, how many should the plant manager expect to discard? Well, if this percent is discarded of the 30,000, well, we just have to figure that out. 0.0124 are discarded of 30,000. Anytime we read a statement like that, 0.0124 of another number, that means we multiply. So 0.0124, we're going to times that by 30,000 and figure out how many we would have to probably discard. So 30,000. So you just type that into a calculator and I got 372. That is real life. When you run a plant, you will have variability in what you produce, and you will have a standard that it must be between, that you tell your customers, it will be between here and here. And anything outside of that, you have to get rid of. So you check those things. Okay. So that is the end of 7.2, working with the normal curve. I hope that was enough examples to show you how to really be comfortable with the normal calculator in StatCrunch. As always, if it's not enough or you need another example, please just reach out to me. Any videos that I create for anybody else, I will post onto Blackboard. So anytime you have a question, please just ask. It helps you and everybody else out.